The National Electrical Code, or NEC, serves as a minimum standard for electrical safety in the United States. Most states and local jurisdictions, including Illinois, have adopted and enforced it. In Illinois, the Illinois Commerce Commission, also known as the ICC, adopted the NEC as the electrical code. However, some counties in Illinois do not have adopted building codes. This means there is no legal requirement for an electrician to follow the NEC in those specific counties. It is still considered the best practice and standard of care for electricians to adhere to the NEC even in areas where it is not legally required. Violating the NEC, even where it is not legally required, can lead to several serious consequences. Firstly, safety hazards. Non-compliant electrical work can create electrical fires, shocks, and other safety risks. Secondly, insurance claims. Insurance companies may deny claims for electrical damage if the work was not done in accordance with the NEC. Thirdly, property value. Homes with non-compliant electrical work may have reduced property value. Despite the lack of legal requirements in certain counties, there are several options. Firstly, discuss the issues with the electrician who performed the work and express any concerns about the violations and see if they are willing to correct the issues. Secondly, hire a licensed and certified electrician to inspect and rewire the home to code. Thirdly, contact the Illinois Commerce Commission, that is, the IC. You can report the violations to the ICC. However, they may not have jurisdiction to enforce the NEC in your specific county, but they may provide some guidance. It is highly advisable to have electrical work done in accordance with the NEC, even if it is not legally required, to ensure the safety of the home, protect insurance claims, and maintain property value. The NEC is a comprehensive set of standards designed to ensure electrical installations are safe and reliable. It covers a wide range of topics, including wiring methods, overcurrent protection, grounding, and equipment installation. Adhering to the NEC helps to minimize the risk of electrical fires, shocks, and other hazards. Let's delve deeper into some specific areas of the NEC and their importance. Firstly, wiring methods. The NEC specifies acceptable wiring methods for different applications such as residential, commercial, and industrial settings. These methods include using the correct type and size of wire, properly securing and protecting wires, and maintaining proper spacing between wires. Secondly, overcurrent protection. Overcurrent protection devices such as circuit breakers and fuses are designed to protect electrical circuits from overloads and short circuits. The NEC specifies the appropriate size and type of overcurrent protection for different circuits, ensuring that the devices will trip and interrupt the flow of electricity in the event of a fault. Thirdly, grounding. Grounding is a critical safety measure that helps to protect against electrical shock. The NEC requires that all electrical systems be properly grounded, providing a path for fault current to flow back to the source, tripping the overcurrent protection device and energizing the circuit. Fourthly, equipment installation. The NEC provides detailed requirements for the installation of electrical equipment such as receptacles, switches, lighting fixtures, and appliances. These requirements ensure that the equipment is installed safely and correctly, minimizing the risk of electrical hazards. The NEC is updated every 3 years to reflect advancements in technology and changes in industry best practices. It is important for electricians and other electrical professionals to stay up to date with the latest edition of the NEC to ensure that their work complies with the most current safety standards. Now let's consider some common NEC violations and their potential consequences. 1. Improper wiring methods. Using the wrong type or size of wire, failing to properly secure wires, or running wires through unprotected areas can all lead to electrical hazards. For example, using undersized wire can cause the wire to overheat and potentially start a fire. 2. Inadequate overcurrent protection. Installing overcurrent protection devices that are too large for the circuit can prevent them from tripping in the event of a fault, increasing the risk of electrical fires and equipment damage. 3. Improper grounding. Failing to properly ground electrical systems can increase the risk of electrical shock. For example, If an appliance is not properly grounded, a fault in the appliance can cause the metal casing to become energized, potentially shocking anyone who touches it. 4. Improper equipment installation. Installing electrical equipment incorrectly can also lead to safety hazards. For example, failing to properly tighten connections on receptacles or switches can cause them to overheat and potentially start a fire. If you suspect that your home's electrical system has NEC violations, it is important to take action to correct the issues. Firstly, contact a qualified electrician to inspect the system and identify any violations. Secondly, have the electrician correct the violations in accordance with the NEC. Thirdly, consider having the electrical system inspected by a third-party inspector to ensure that the corrections were done properly. In addition to the NEC, there may be other applicable codes and standards in your area. For example, some local jurisdictions may have their own electrical codes that are more stringent than the NEC. It is important to be aware of all applicable codes and standards to ensure that your electrical work complies with all requirements. Let's discuss the role of licensing and certification in ensuring electrical safety. Many states and local jurisdictions require electricians to be licensed or certified. Licensing and certification demonstrate that an electrician has met certain minimum qualifications and has the knowledge and skills necessary to perform electrical work safely and competently. When hiring an electrician, it is important to verify that they are properly licensed and certified. This can help to ensure that the electrician is qualified to perform the work and that they will adhere to the NEC and other applicable codes and standards. Now let's explore some additional resources for learning about the NEC and electrical safety. The National Fire Protection Association, that is, NFPA, publishes the NEC and offers a variety of training and educational resources on electrical safety. The International Association of Electrical Inspectors, also known as the IE, is a professional organization for electrical inspectors and offers training and certification programs for electrical professionals. Many community colleges and technical schools offer courses in electrical wiring and the NEC. Online resources such as websites and forums can also provide valuable information on electrical safety. Remember, electrical safety is paramount. By understanding the NEC, adhering to its requirements, and hiring qualified professionals, you can help to protect your home and family from electrical hazards. Now let's explore some advanced topics related to the NEC and electrical installations. Firstly, surge protection. Surge protection devices, or SPDs, are designed to protect electrical equipment from voltage surges, such as those caused by lightning strikes or power grid fluctuations. The NEC requires surge protection in certain applications, such as critical facilities and dwelling units. Secondly, arc fault circuit interrupters. Arc fault circuit interrupters, also known as ASIs, are designed to detect arc faults, which are dangerous electrical conditions that can lead to fires. The NEC requires ASIs in many circuits and dwelling units, such as bedroom circuits. Thirdly, ground fault circuit interrupters. Ground fault circuit interrupters, referred to as GFCIs, are designed to protect against electrical shock by detecting ground faults, which occur when current leaks to ground. The NEC requires GFCIs in many locations, such as bathrooms, kitchens, and outdoor areas. Fourthly, renewable energy systems. The NEC includes specific requirements for the installation of renewable energy systems, such as solar photovoltaic systems and wind turbines. These requirements address the unique safety considerations associated with these systems. Fifthly, energy efficiency. The NEC promotes energy efficiency by requiring the use of energy-efficient lighting and equipment in certain applications. The NEC also includes requirements for energy management systems, which can help to reduce energy consumption. Let's discuss some common misconceptions about the NEC. One misconception is that the NEC is a design guide. The NEC is a safety standard, not a design guide. It provides minimum requirements for electrical installations, but it does not provide detailed design guidance. 2. Another misconception is that the NEC is a one-size-fits-all solution. The NEC is a flexible standard that can be adapted to different applications. However, it is important to understand the specific requirements of the NEC and to apply them appropriately. 3. A further misconception is that the NEC is only for electricians. The NEC is a valuable resource for anyone involved in electrical work, including engineers, inspectors, and homeowners. 4. Another misconception is that the NEC is too expensive. The NEC can add to the cost of electrical installations, but it is important to remember that the cost of electrical safety is far less than the cost of an electrical fire or shock. Now let's consider some of the challenges associated with enforcing the NEC. One challenge is that the NEC is a complex and technical document. It can be difficult for inspectors and other enforcement officials to understand and apply the NEC correctly. 2. Another challenge is that the NEC is constantly evolving. The NEC is updated every 3 years, and it can be difficult for enforcement officials to stay up to date with the latest changes. 3. A further challenge is that there is a shortage of qualified electrical inspectors. This shortage can make it difficult to enforce the NEC effectively. 4. Another challenge is that some jurisdictions do not have adequate resources for enforcing the NEC. This can lead to inconsistent enforcement of the NEC. Now, let's discuss some strategies for improving NEC enforcement. One strategy is to provide better training for electrical inspectors. This training should cover the latest edition of the NEC and should focus on practical application of the code. 2. Another strategy is to increase the number of qualified electrical inspectors. This can be done by offering incentives for people to become electrical inspectors and by providing scholarships for training programs. 3. A further strategy is to provide more resources for NEC enforcement. This could include funding for additional inspectors, equipment, and training. 4. Another strategy is to promote public awareness of the NEC. This can be done through public service announcements, educational materials, and outreach programs. Let's delve into the process of adopting and amending the NEC at the state and local levels. The NEC is developed and maintained by the National Fire Protection Association, the NFPA, through a consensus-based process that involves a wide range of stakeholders, including electrical engineers, contractors, inspectors, and manufacturers. After the NEC is published, it is up to each state and local jurisdiction to decide whether to adopt it as their electrical code. Some jurisdictions adopt the NEC in its entirety, while others amend it to reflect local conditions and priorities. The process of amending the NEC can vary depending on the jurisdiction. In some jurisdictions, amendments are made by the state legislature or local governing body. In other jurisdictions, amendments are made by a technical committee or board. It is important to be aware of the specific requirements of the NEC and any local amendments when performing electrical work. Now, let's discuss the role of product safety standards in ensuring electrical safety. Product safety standards, such as those developed by Underwriters Laboratories, also known as UL, and other organizations, set minimum requirements for the safety of electrical products. These standards help to ensure that electrical products are designed and manufactured to be safe and reliable. The NEC requires that electrical products be listed or labeled by a recognized testing laboratory such as UL to indicate that they meet applicable product safety standards. When selecting electrical products, it is important to look for the UL listing or labeling to ensure that the products have been tested and certified to meet safety standards. Let's explore the relationship between the NEC and other codes and standards. The NEC is not the only code or standard that applies to electrical installations. Other codes and standards, such as the International Building Code, the International Residential Code, and the National Fuel Gas Code, may also apply, depending on the specific project. It is important to be aware of all applicable codes and standards and to ensure that your electrical work complies with all requirements. For example, the International Building Code and the International Residential Code contain requirements for the structural integrity of buildings, which can affect the installation of electrical systems. The National Fuel Gas Code contains requirements for the installation of gas piping systems, which can affect the location of electrical equipment. Now let's discuss the importance of ongoing education and training for electrical professionals. The electrical industry is constantly evolving, with new technologies and techniques being developed all the time. It is important for electrical professionals to stay up to date with the latest developments by participating in ongoing education and training. There are many opportunities for electrical professionals to obtain continuing education, such as courses offered by trade associations, community colleges, and online providers. Continuing education can help electrical professionals to improve their skills, knowledge, and safety practices. Now let's discuss some best practices for electrical safety in the home. Firstly, inspect electrical cords and appliances regularly for damage. Replace any damaged cords or appliances immediately. Secondly, avoid overloading electrical circuits. Do not plug too many appliances into a single outlet or extension cord. Thirdly, use ground fault circuit interrupters, or GFCIs, in bathrooms, kitchens, and outdoor areas. Fourthly, keep electrical equipment away from water. Fifthly, have your electrical system inspected by a qualified electrician every few years. Sixthly, install smoke detectors and carbon monoxide detectors in your home. Test the detectors regularly to ensure that they are working properly. Seventhly, develop an escape plan in case of a fire. Practice the plan with your family regularly. Let's explore some advanced topics in electrical troubleshooting. Firstly, understanding electrical schematics. Electrical schematics are diagrams that show the connections between electrical components. Being able to read and interpret electrical schematics is essential for troubleshooting electrical problems. Secondly, using electrical test equipment. There are many different types of electrical test equipment, such as multimeters, clamp-on ammeters, and insulation testers. Knowing how to use this equipment safely and effectively is essential for troubleshooting electrical problems. Thirdly, troubleshooting common electrical problems. Some common electrical problems include open circuits, short circuits, and ground faults. Knowing how to identify and troubleshoot these problems is essential for maintaining electrical safety and reliability. Fourthly, understanding electrical theory. A solid understanding of electrical theory is essential for troubleshooting complex electrical problems. This includes understanding concepts such as voltage, current, resistance, and power. Fifthly, using a systematic approach to troubleshooting. A systematic approach to troubleshooting can help to identify the root cause of electrical problems quickly and efficiently. This approach typically involves gathering information, analyzing the problem, developing a plan, and testing the solution.